All right, so welcome to the first in a bunch on periodic trends. This is kind of introduction. This is some background information that you need for the rest of it to make sense. So let's get into it. This is our standard. Describe the relationship between the structure of the periodic table and the arrangement of electrons, the general properties of an element, and the periodic trends for attraction of electrons and atomic radius. So there's 4 trends we're going to be going over: atomic radius, ionization energy, electronegativity, and ionic radius. So we'll have one on each one of these. This first one, though, like I said, is just the background information you need for all of them. So here's a general note. All right, so we got to hit some key vocabulary on this that we need for all of this. So the first one is periodic. We call it a periodic table for a reason, because it is the patterns on the periodic table repeat. So periodic, a couple different places you might see it, is periodic, like, so the period of a pendulum is a thing that swings back and forth like that. When in physics, we say the period of a pendulum is the time it takes for the pendulum to swing one direction and then back. So it's how long it takes for it to repeat. The other one that people hear the most is for the menstrual cycle for females. We call it, girls get their period. That is because it's actually a repeating cycle. Every 28 days or so, the cycle occurs. Wow, the bells are annoying right now. So the uteral wall builds up. It gets to a certain point. The hormones change. That material sloughs off, which is what we call the period, but it's all part of the same cycle. And then it repeats. And it continues over and over again every 28 days approximately. So a periodic table, you could almost think of it like a typewriter. Like you type in on a typewriter. If you guys have seen pictures of people using them, they hit the end, they go ding, they hit the button, it goes back, and it advances up the line. So that's what happens with the periodic table. It goes all the way, the trends go all the way across. You hit the end, the noble gases, ding, we start back over, one row down at the beginning. So that's why it's periodic. It's a repeating pattern. Okay, periodic law is the idea that elements are arranged in order of their atomic number, and their physical and chemical properties show patterns. And we're going to be looking at those different patterns that they show throughout this unit. Groups or families, whenever we're talking about groups or family, these are the columns on the periodic table, so the up and downs. We're going to go over some specific ones on the next slide. And then the rows on the periodic table are called periods. Period 1, period 2, period 3, all the way through 7. So instead of saying rows, from now on we're going to say periods. Oh, this does come back to, by the way, periodic, another repeating pattern. There's a reason why you're in first period, second period, third period. We have a set of periods that we repeat over the course every school day. And then valence electrons, these are come up way more in the next unit. Those are just the electrons on the outermost electrons on an atom. Basically, they're the ones that are in the S and P suborbitals. The D and the F are weird. We don't really count them as valence electrons. So it's just however many S and P electrons that are in the S and P suborbitals. That's what we call valence electrons. All right, so we're talking about the groups. Remember, groups are the columns on the periodic table. So there's a couple of key ones we need to know about. So the first group, the alkali metals. Not counting hydrogen, ignore hydrogen, hydrogen special. This first column on the periodic table, these are known as the alkali metals. The second column on the periodic table, starting with beryllium and down, these are the alkaline earth metals. Okay, these guys, we've talked about them a little bit before. These whole group, the D block from electron configuration, these are all known as the transition metals. We have the rare earth metals. The rare earth metals are down here. They are, these are the ones we called the F block in the previous unit. Those are the rare earth metals. Halogens. Halogens are special. They are this table here, this column here on the periodic table, fluorine, chlorine, bromine, iodine, hafnium. They are super reactive. They come up a lot. That's why they have their own special name. And then the noble gases, the final column on the periodic table that we care about. These are the noble gases. A different color. Noble gases. They are very stable. They have, if you remember, these all have we say, except for helium, they have 8 valence electrons because they have 2 in the S and 6 in the P. So they have a total of 8 valence electrons. Like I said, we'll get into those more next unit, but that makes them very, very stable. All right. Other than, there are three different, there are names of other groups, like this is the boron group and the carbon group and the nitrogen, but we don't talk about them very much, so I'm not going to make you know those for this. Remember, we have metals on the periodic table, metalloids, and non-metals. So the metals on the periodic table, most of the periodic table is metals. We have this line that we draw right here, this line. So on this side of the line, we have metals, which I can spell. And this side of the line, we have non-metals. And along the line, the staircase, those are where we get the metalloids. Okay. Aluminum is a metal, but the rest of these guys, boron, silicon, germanium, arsenic, antium, tellurium, polonium, these are all metalloids. So this side non-metals, this side metals, these are metalloids except for aluminum. So those are the groups that you need to know, and types. All right, so periodic trends, the word you probably hear trends with the most is the idea like fashion trends, right? It's how things are going. Like not everyone's wearing exactly the same thing, but in general, like right now in the trends, when I started teaching, the trends were all the girls in every one of my class had really low-cut jeans. Like it was those low-cut jeans that everyone had to worry about their underwear showing. And over time, the trend has been to go higher and higher and higher. So now, most of my students have what I call, when I was in high school, mom jeans, which are like really, really high-waist jeans. That's been the trend. Over 10 years that I've been teaching, the trend has gone, the height of the jeans has gone up and up and up. That's a trend, okay? We normally call it gradual increase or decrease. So it doesn't go like suddenly, doesn't jump up, it's not always perfect. Like some years people suddenly go back to the old style jeans, or sometimes they come, it's not a perfect example, but it's in general the trend is towards something, whether it's increasing or decreasing. Those are periodic trends. So all of these trends are dependent upon two key properties. We're going to keep referring back to these. They have to do with the highest energy level. Okay, so if you remember, if we picture our periodic table, all right, we have our periodic table, and you remember when we did electron configuration, this is period 1, period 2, period 3, period 4, all the way down. Every time you go down a row on the periodic table, you're adding another layer of electrons. So this has the first layer of electrons, level 1, and then now we have the 2s and 2p and the 3s and 2. So you have that first energy level, the 1, and then you have you go down a row, and now you have the second energy level. And you go down another row, and now you have the third energy level. So wherever the electrons are, the furthest out, that affects the size, affects all of these trends. The other one is, remember, as you go from left to right on the periodic table and down, the number of protons increase. So 1, 2, 3, 4. You start having more and more protons as you go down, and more electrons. So the number of protons and the number of electrons you have an impact on an element, or on these different trends that we're going to be looking at. So we're going to be looking at 4 trends, and we'll have one little mix for each one. The atomic size, the ionization energy, the ion size, and electronegativity. All of these, you'll go back to the previous slide, the second slide. These are all the 4 trends that you need to understand their properties as they go across and as they go down the periodic table.